Yes. Part 6, we learn graph of cubic functions. How to sketch the cubic graph. Sketch the graph of the function f of x equal to x cube minus 6x square plus 9x. The x-intercept, as usual, we calculate x-intercept, y-intercept, and the turning points. Here it is a cubic graph. Okay, we start with x-intercept. Let y equal to 0. So we substitute 0 for y. 0 equal to x cube minus 6x square plus 9x. Then we factorize very carefully. Here x is common. So we have x square minus 6x plus 9 inside the bracket. Again we factorize. We get x minus 3 times x minus 3. So the values x equal to 0 or x equal to 3. You can see x minus 3 again. So that x-intercept at 3, 0 is also a turning point of the graph. Remember that. Now we move on to the y-intercept. We already know x coordinate will be 0. So we substitute 0 for x. Then we get 0. So the y-intercept is also there now. The next is the turning points or the stationary points. Here it is a cubic graph. So we may have one turning point or two turning points. Look at the method. We already learned that at the turning point, the derivative of the function will be equal to 0. The gradient of the tangent will be 0. So f dash x equal to 0. We find the derivative of the function. What is that? 3x square minus 12x plus 9 equal to 0. We do all these type of questions after learning differentiation, how to find the derivative. We learned that using rules. Therefore, we simplify. Divide by 3, we get x square minus 4x plus 3 equal to 0. Therefore, factorize x minus 3 times x minus 1 equal to 0. We get two values for x equal to 3 or x equal to 1. Then we go for the y coordinates. We substitute the corresponding x values. So x is 3. We simplify on the calculator. You do it on the calculator. We get f of 3 equal to 0. F of 1 is equal to 4. So the turning point, we have two turning points now. The first one is 3, 0. Another one is 1, 4. So that is the turning point. Again, we have an important point here, the point of inflection. How do we calculate that? In the previous video, we have seen f double dash x equal to 0. The second derivative equal to 0. So first you get the derivative. You find the derivative again. Derivative of derivative. Second derivative. So we get f double dash x equal to 6x minus 12 equal to 0. Solving that, we get x equal to 2. Go for the y coordinate. When x equal to 2, where do we substitute? Go to the original function. So we have 2 cube minus 6 times 2 square plus 9 times 2 equal to. We get 2. Remember that we are not substituting the x value in f dash x or in f double dash, only in the original function. So the point of inflection is 2, 2. Now we discussed about the shape of the graph depending on the value of a, the coefficient of x cube. What is the number here? It's 1, positive 1. So we must have an idea of the shape. And we have 2 turning points. So we start sketching on the Cartesian plane, y-axis, x-axis. We mark the important points there. And we get the y-intercept, the turning point number 1, turning point, as well as another x-intercept. That is our graph. So the point of inflection is also marked 2, 2. We get a beautiful cubic graph. Lot of marks. Sketch the graph of another function, gx equal to minus x cube minus 1. Okay, start. We get x-intercept. We put y equal to 0. Then x cube equal to minus 1. Cube root of x is minus 1. So the x-intercept is minus 1. Y-intercept, x equal to 0. We get minus 1. So y equal to minus 1. Now, look at that. Turning points, or another name is stationary points. G dash x equal to 0. Already we learned the method now. So we get the derivative minus 3x square equal to 0. Therefore, x square equal to 0. X equal to 0. Go for the y coordinate. So all repetitions, you see. Y coordinate, we get g of 0 is minus 1. Turning point, 0 minus 1. Look at that, only one turning point. When you have only one turning point, keep in mind that that turning point itself is our point of inflection, because we don't have two turning points here. So that is a difference in this question. Now we sketch. What is the shape? The value of a is negative 1. So the shape, we must have an idea of that. We mark the important points there. The x-intercept, the y-intercept, and the turning point, 0 minus 1. What is the point of inflection? 0 minus 1. So we got the sketch graph of G. Moving to another question, we are learning how to sketch the cubic functions. Minus x cube minus 4x square plus 3x plus 18. X-intercept. Minus x cube minus 4x square plus 3x plus 18 equal to 0. Change the sign. We are trying to factorize very quick. Look at the 4 terms. So you can also use your calculator in the table mode. You take the table mode and punch f of x. You will get the x and y. When you see y 0, that is the value of x. So you can get also from the calculator. You are allowed to use the calculator also. So we get the factors. X minus 2 times x square plus 6x plus 9. Factorize x plus 3 times x plus 3. So x equal to 2 or x equal to minus 3. Look at that, x plus 3 times x plus 3. So that point is an x-intercept as well as a turning point. Y-intercept. Put 0 for x and then we get 18. So the y-intercept is 18. Third step, turning points. F dash x equal to 0. Do it very carefully. These are all actually after getting the derivative, it is calculations. Use your calculators. So minus 3x square minus 8x plus 3. The derivative equal to 0. Change the sign. Factorize. Slowly we get x equal to 1 over 3 or x equal to minus 3. Y coordinates. Substitute the x value into the function. Use your calculator. You get 18 and 14 over 27. Again, substitute minus 3. Another y value, that is 0. So, the turning points, we have two turning points here. 1 over 3, 18 and 14 over 27. Minus 3, 0. Now, what is the next one? Point of inflection. F dash x equal to 0. That is, no, not f dash x, f double dash x equal to 0. So we calculate f dash x, then you differentiate once more. We get minus 6 minus 8 equal to 0. X is minus 4 over 3. Substitute minus 4 over 3 for the y coordinate. We get 9 and 7 over 27. Use your calculator properly. The point of inflection is minus 4 over 3. 9 and 7 over 27. Now the shape, what is the a? Minus 3, less than 0, negative number. So the shape you must have an idea. And we have two turning points. Okay. Then we have the Cartesian plane. We start sketching the graph. Mark all the points very, very carefully. X-intercept, y-intercept, the turning point, point of inflection. Here is the graph of F. Beautiful question. That is the end of part 6. So we understood how to sketch the cubic graph. The method is very, very simple, very clear. Only problem is the accuracy. Be careful in the calculations. You are applying calculus in sketching a cubic graph. Watch the video again and again. Share it. Thank you.